I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to share with you a very important question based on combinatorics, especially for IB Math SL students. Now, in the solution of this problem, we will understand when to use permutation and when to use combination, rather, how to use combination, right? Now, let me thank all the viewers and subscribers for watching my videos, posting excellent comments and remarks. This question comes from our subscribers. Well, you enjoy a privilege that you can always post a question to me and I can provide you with a video solution, just as we are doing this. And this request comes from Pakistan. Perfect. Now, let us see. How do we answer this question? Which is an application password with exactly 6 characters is to be chosen from the following set of 10 characters symbols dollar sign, exclamation sign, ampersand sign, letters A, B, C, D, and numbers are 2, 3, 5. So these are the 10 characters we're talking about. Each character is to be used only once in the password. Find the number of possible passwords that can be chosen if. So, three parts. One, no restriction. There are no restrictions. Second, each password must start with a symbol and end with a letter. And C is each password must contain at least one symbol, right? At least one symbol. So these are the three parts to it. You can always pause the video, answer the question, and then look into my suggestions. You can also contribute to our passion of sharing by sending an email and discussing different methods. Perfect. Now let's see how do we solve each one of them one by one. The very first one is that we are using 10 characters, right? So we have 10 characters. So let me write down 10 characters. And no restriction. But there is one restriction that only once, right? Means you cannot repeat them. And a password which has exactly 6 characters. So you see, I have highlighted the key issues. Now, we will do like this. We have 6 spaces 1, 2, 3, 4, 5, 6. So these 6 spaces are there. We have to use any one of these 10, right? How many different ways? Well, to choose for the very first spot, we have 10 options, right? Total number of options are 10. But once we make a selection, we are left with 9 out of these. So there are 9 options. If you take 9, 8 are left. Similarly, 7, 6, and 5, right? So your answer is that the choices are 10 times, 9 times, 8 times, 7 times, 6 times 5. In the short form, this is the permutation, right? You have choices from 10, right? And you could put them in 6 different spots, right? So we have distinct objects, correct? Try to understand. Distinct objects, no repetition, and we have 6 places to arrange them in a row, right? So whenever we are arranging them in a row, in that case, position matters, right? So key point here is position matters, is important. And therefore, we have permutation, right? So permutation is what it is. And when you use calculator to multiply this, you get what? So you have this function 10p6 on the calculator. Please calculate. And what you get here is the answer, which is 151 200. So you can try it just now, just check your answer. So I hope this part is absolutely clear, right? It is a case of permutation. Now, let's look into the second part. Part B is each password must contain at least, oh, that is part C, sorry. Part B is each password must start with symbol and end with letter. So now we have part B, which is must start with symbol and end with letter. Perfect. So again, we have these six positions: one, two, three, four, five, six. In the first position, you can start with symbol, right? So we have symbol here, right? And at the last end, we have letters. As far as symbols are concerned, we have three symbols, right? So we have three choices. As far as letters are concerned, we have four choices. Correct? You can fill in the others with any other thing. Correct? You get the idea? So I like you to now pause the video, complete the answer, and check with my solution. Well, in case you want to learn from me directly, send an email to globalmathinstitute@gmail.com. Also, check our website, Global Math Institute, for latest updates. As you know, my students are always there on the top. So, I can be part of your success story. Correct. Now, what remains here is that we have already decided that we need to start with symbol. There are only three symbols with us, right? So that gives us three choices. We have to end with letters. We have four letters A, B, C, D. One of them will come here. So we have got four choices as far as letters are concerned. Now, what remains is to fill these four positions, right, with 2 out of 10 has been taken out. So out of 8, we have to take 4 positions. It is a case of permutation again. It is a straight row. Position matters. Distinct objects. Distinct not being repeated, right? So we have 8p4 options. And therefore, the answer will be 3 times 8p4, right? Times 4. That is the answer. So you can use the calculator and find this answer also. You get the idea, right? 8p4 really means 8 times, 7 times, 6 times 5. Multiply them with 3 and 4 to get your answer. So when I use the calculator, I get the solution and the answer is 20160. So there are 20,160 ways in which we can create this 6 character password from the given set of characters, right? Where they cannot be repeated. They can be used only once, starting with symbol, ending with letter. Clear? Perfect. Let's move on to the last part, which is actually the difficult portion, and because of that, this request has come, right? So, to explain it in details, I will actually help you understand the concept in two different methods, right? Since it is difficult for students, let's really work with two different methods. Once again, you can join my classes by sending an email to globalmathinstitute@gmail.com, and then you will see the success. Great. So let me call the first one as method 1. So again, the problem is that we need to create a password with exactly 6 characters. Nothing repeats. We have 10 characters at hand to choose from. Symbols, there are 3 symbols. four letters, and there are three numbers. Now it says each password must contain at least one symbol. You get the idea. So in part A, we had done without restriction, means there was no restriction, then how many conditions are there, right? So basically, what we can do is we now want to find at least one symbol. That means the total number of ways, which was without restriction, right, minus no symbols, minus no symbols at all. That means we'll have at least one. You get the whole idea. This is very useful approach, right? So complement really helps us to work with such questions very easily. So I will adopt this method as the preferred method to answer this question. Without restriction, well, simple. We have 10 characters, 6 positions, means 10p6, correct? No symbol means we are only using 4 letters and 3 numbers, means 1, 2, 3, 4, 5, 6, 7. So minus out of 7, we select 6, and that gives you the answer. You get the idea? So that is our answer for part C, where at least one symbol has been used. So from all possible combinations of these passwords, we have to take away those in which there are no symbols at all. Then we are left with those which have at least one symbol. Makes sense, right? That is what key is for this particular solution. And let me now check with calculator. 10p6 we know minus 7p6. It gives me the answer as 146, 160. Is that clear to you? So that becomes the solution, method 1, for the given situation. Now let's look into the alternate method, right? So now we talk about alternate method. Can you suggest one? Well, that could have been your first method, right? Or we can say method 2, right? Okay, method 2. Once again, just a reminder, you can subscribe, and when you subscribe, you get an advantage of posting questions to me, which I'll answer in the form of videos, right? And you can, of course, give me suggestions and questions that can help enrich our YouTube channel. It is your channel, right? Now, once again, we have to find the number of passwords with exactly 6 characters, right? Chosen from 10 characters, given symbols, 3 of them, letters, 4 of them, numbers, 3 of them. Each password must contain at least one symbol. It means we can look into different cases, right? So, case 1, case 2, and case 3. So, many times we adopt this method of case study. So, in case 1, we can have one symbol. Case 2, we can have two symbols. Or we could have three symbols. There are three only, right? All the three. Correct. So you get the idea, right? So these are the. So we need to now find different combinations with these conditions, right? Now let us say that we can have one symbol. So one symbol means what? We have 6 positions, right? One, two, three, four, five, six. Now let us try to choose a symbol. See, there are three symbols, so we need only one. So we have three choices. We have three choices. So this is one thing which we have, correct? Now, out of these three choices, since we have only one symbol, this choice could be in either one of these places, correct? Right? So, so this one number could be on any one of these places, correct? So the combination 1, 2, 3, 4, 5, 6, right? So we have 6C1, so we have 3, look at it, times 6C1, that this number can be anywhere. You get the idea. Now, in the other positions, we are free to choose only from the letters and the numbers, no more symbols, because we wanted one symbol, we have already selected. So we're left with 1, 2, 3, 4, 5, 6, 7. Correct? So we have 7p, and out of 7, we are left with only 5 positions, which could be any 5, and that becomes our answer. You see that? So we'll multiply this by 7p5. You see how we have used combination and the concept of permutation to get this answer. Now, when you multiply this, you get your answer as equal to 45360. So that is your case 1, correct? Now let's do case 2. You can actually now pause the video. You have understood the concept and then check with my solution. 1, 2, 3, 4, 5, 6. Once again. Now we want two symbols, right? So you have to choose two of them. So we could choose for the first position, we have three choices. Once we do one choice, then we have two choices left. Clear? So we have selected, so there are basically six ways of choosing two from the three symbols, right? This is what we're trying to say, right? Now here we are left with one, two, three, four positions. In these four positions, we can choose from the remaining seven, right? So 7p4, right? Plus, you also understand that these two symbols could be anywhere, right? They could be anywhere amongst this, not necessary that they are first and second, right? You get the idea. So, since these two can be anywhere, what we have for this is 62 combinations. And when we multiply 3 times 2 times 7p4 times 6c2, what do we get? So that is the number of ways in which we can make a password with two symbols. Is that clear to you? Well, I get this as 75600. Perfect. Now let's look into the third choice. And third choice clearly is we want all the three, right? One, two, three, four, five, six. So once we have all the three, the remaining seven can take three positions only, right? So let me start like this. We have taken all the three symbols. Remaining seven can take only three positions. So we go 7p3, right? This time we are giving others as the priority and all the three, right? So as far as all the three is concerned, which is 3 factorial, right? You can say 3 times 2 times 1, correct? Now, these three could be in different positions, so you could choose any three positions from the six available. You get the idea. That is how the combination comes into picture. Perfect. And the total number of ways is 200. Correct. Now we need to add them up to write down how much all of them could be, right? So we can write at least one symbol, add them up. So when you add, what do you get? So we are adding these three quantities, correct? So 0, right? And then we get 6, correct? 6, and you get 1, 6, 4, 1, correct? So 146, 160 is the total number of ways when you can make this password with at least one symbol. Perfect. So that is how we are going to answer this particular question. I hope it makes sense, right? So, wonderful question. Let me thank once again our subscriber for sharing such a beautiful problem for us, right? And I'll request all others to, whenever you have difficulty and you need to get your doubts cleared, feel free to send an email to globalmathinstitute@gmail.com. I will be answering your questions and I may make a video for it, right? That is also possible. Thanks for your time and join our classes for the ultimate success path. As you can see, that is our motive. Thank you and all the best.